I have a basic and dumb question. Why does every action have an equal and opposite reaction? When I push against the wall, I generate the motive force. I feel my hand pushing against the wall. Why is the wall pushing back? Who is there to push back? What is there to push back? Is this just something we memorize from Newton, or is it some underlying explanation?
There is an underlying deeper explanation. Fundamentally, all pushing of your hand against the wall is actually repulsion of electrons. So it fundamentally comes down to the atoms out of which your hand is made pushed up against the atoms out of which the wall is made. And those atoms pushing against those atoms between your hand and the wall are electrons repelling from your hand against the electrons in the wall. Of course, Newton didn't know about electrons, but he understood that much. He thought of, for example, gravity as being a force, of course. And so if you have the gravity of an object sitting on the ground, okay, you're sitting on the floor, let's say, then the floor is pushing up against your butt. Newton understood that if there wasn't a pair of forces like this, if there was only a force of your butt on the floor and nothing to push from the floor on your butt, then you'd just fall through the floor to the center of the earth. So that's the logical reason why there has to be this pair of forces. If you're pushing against the wall, then if there was no push of the wall against your hand, then your hand would go through the wall. That's not what happens. So by logic, there has to be this pair. Now the question might logically come, what about in free fall? If you've jumped out of the aeroplane, you haven't pulled the parachute yet, you're falling towards the earth. On Newton's view, when an object falls towards the earth, yeah, okay, then the earth is pulling on that object downwards. So where's the opposite reaction force in the other direction? Isn't there only one force, namely the gravity of the earth pulling you down? Where's the equal and opposite force? After all, you're not on the ground. There's gravity pulling down, but unlike with those first examples I talked about where you're sitting on the ground, there appears to be no surface beneath you pulling you down. So where's the pair of forces here? One force is the gravity of the earth pulling on the object that is falling towards the earth. You've jumped out of the aeroplane, you're falling towards the earth's pulling on you. Where's the second force? Aha! The equal and opposite force is you pulling on the earth. And it's an equal and opposite force because the earth's big force of gravity on you is actually small because you're small. So it doesn't need to pull on you very much. And on the other hand, you, having a small mass, have gravity yourself pulling on the huge earth, which is a small force. And so therefore, these two forces are equal and opposite. And that's the second force. You pulling on the earth and the earth's pulling on you. So on Newton's view, these are pulling forces. Unlike with the first situation where you're sitting on the ground, where they're pushing forces. I was also asked if centrifugal force is a real force or a fictitious force. In other words, does centrifugal force even exist? So there are three answers to this. On the one hand, yes, just turn a corner in your car, or as an aeroplane goes around in a circle. The feeling you get is a real feeling, and that requires explanation. What you feel when you go around a corner is you're pushing up against the door of the car. And that's real, and that demands an explanation. But the correct explanation really is that there is a centripetal force or centripetal force, however you want to describe this, and that is the car pushing you against the door against you or the seat against you, whatever you want to call it, and that's making you go in a circle. And you feel that as what's described as a centrifugal force, the feeling. And so the feeling demands an explanation, and sometimes people say, well, this is the centrifugal force. So in that sense, it's not really real because, in fact, it's the centripetal force that is pushing you in one direction. But forces do come in pairs. So if there's a centripetal force in one direction, then there's a normal force in the other direction, as we've already explained in the previous answer. And so therefore, you can call this normal force the centrifugal force. But people do say it's incorrect to phrase things that way, that the centrifugal force is a specific name for a specific force, and calling it the normal force is not correct. I disagree, but let's put that aside. Centrifugal forces are also real from the perspective of they are a consequence of the frame of reference choice. So you pick your inertial frame of reference, and what happens is that under those circumstances, you absolutely do get a centrifugal force. In other words, if you look at the classic example for this is like you've got a disc spinning around and you've got something on the disc. Like, let's say you're looking at a bug that's on the disc as you spin the disc around. The bug's going to travel from the center of that disc to the outside of the disc. Now, why does it move that way? Something's pushing it. Something's definitely pushing it that way. It's accelerating towards the outside, and so looked at in a certain way, that push of the bug from the center of the circle to the outside of the circle, that motion, that acceleration, is explained by a force, and so you can call that force the centrifugal force. So the three answers in summary are: centrifugal force exists because it's the feeling you get of pushing up against the door. 2, the centrifugal force doesn't exist because that feeling is only apparent. The third answer is forces come in pairs, so it exists, and or the centrifugal force is a consequence of your perspective of which frame of reference you're talking about. So make your choice on whether or not the centrifugal force exists. I say it exists. Other physicists disagree. Ultimately, it doesn't matter. The question is, do you understand that forces come in pairs? Do you understand what a frame of reference is?
So in one of the comments, James Clerk Maxwell had a good thought exercise about pushing a basketball in outer space. Obviously, you push the ball pushes back, you both fly apart. But does the equal and opposite reaction come from the force that you applied being split in half? Or is there, just the definition of forces is such that forces are always split in half? The motive force to push the basketball came from you, the individual, but yet there's an equal and opposite reaction. So where does the energy for that force come from, that pushing back force?
Questions. There are questions. I'm so excited. This is just an introduction to answers. I apologize firstly for any noise. I'm staying with family who are loud, including some children who are unavoidably loud. So there may be interruptions to this. We'll see.